Hey guys, Mr. Dell again. Hey, I am going to do a couple examples on subtracting fractions. And again, I'm pulling these from the packet that you are working on. I'm going to look at number 15 and I'm also going to look at number 23. Okay, so I'm going to go through, show you how to do some of this subtracting fractions, remind you of the process. So, like I said, we're going to look at number 15. Okay, and number 15 is 7/9 minus 2/6. And again, remember to subtract fractions. When adding and subtracting fractions, you have to have a common denominator. Okay. If you are multiplying or dividing fractions, you do not have to have a common denominator. Only when subtracting and adding fractions do you need a common denominator. So when we look at 9 and 6, those are denominators. They're not the same number. They need to be. So I need a common multiple of 9 and 6. So what goes into 9? I'm sorry, actually, let me say that again. What does 9 go into, as well as what does 6 go into, right? So if we're having trouble finding that, I tend to take the larger number and double it and then just see if it goes into it. So 9 times 9, or 9 plus 9, doubling 9 is 18. And hey, 6 goes into 18. So we're going to use 18. So I need to convert 7/9 into something over 18. And I also need to convert 2/6 into something over 18. So I've got to multiply again. Remember the whole thing about the giant one, right? We're not changing the fraction size at all. We're just changing by multiplying by a giant one. So I need a giant one for both of these numbers. So I'm multiplying to make sure that the number that I'm multiplying is the same top and bottom. In this case, I look at 9 times what is 18. So 9 times 2 is 18. So the giant 1, 2 over 2 is what I have to multiply by. So when I do multiplication, I multiply straight across. 9 times 2 is 18. 7 times 2 is 14. Same thing here. So again, I'm looking to see what times 6 is 18. Happens to be 3. 3 times 6 is 18. So the giant 1, I need to multiply by 3 over 3. And I get 2 times 3 here to be 6. So now instead of, I realize I'm off on my camera there. I'm sorry. Instead of 7/9 minus 2/6, I'm now looking at what? I converted 7/9 to be 14/18. So I'm going to take 14/18 and I'm going to subtract that. Instead of 2/6, I've made it 6/18. Okay. So now I'm taking my converted fractions and subtracting those instead of the original fractions. And again, these are equal statements, just converted fractions. So I can have that common denominator. Oh, move it in. Common denominator of 18. So 14/18 minus 6/18. The denominator stays the same when you're subtracting and adding fractions. The numerator is the only thing you subtract. So I get 14 minus 6 is 8. 8/18. Last thing I might want to do is simplify. Almost said reduce, right? Don't want to reduce because you're not making it anything smaller. You're just simplifying, and simplifying is dividing out the same number, top and bottom. So that way, again, all you're doing is changing it by a giant 1. You're not changing it. You're just simplifying it. You're not reducing it. So I'm going to divide, in this case, what goes into both 18 and 8 is 2. So if I divide top and bottom by 2, I'm going to get 4/9. So my final answer is 7/9 minus 2/6 is 4/9. That's my final answer. Okay. So there's one that has to do with just normal fractions, not mixed numbers. So let's look at one with mixed numbers. For that one, I'm going to look at number 23. Okay, so number 23 is 10 and 3/4 minus 6 and 4/5. All right. This is where, when we're subtracting fractions like we did with adding fractions, with mixed numbers, I could conceivably just subtract the whole numbers and the fractions separately. It's possible, but in this case, because I see that 3/4 is actually smaller than 4/5, if I did that, I'm going to end up with a negative number in the fractions and a positive in the whole numbers, which is going to get pretty crazy. So in this case, I'm going to go ahead this time convert them to improper fractions. So if you remember how to convert into improper fractions, you are taking the 3/4, and so you're now, this 10 is represented as 40 over 4, right? So that 10 is really 40 over 4. It's 10, right? So I'm adding 40 over 4 and 3/4. So 3/4, remember when we looked at this 10 and 3/4, all that represented was 10 plus 3/4. That's what we really had here when we talk about a mixed number. It's really just a whole number added to a fraction. So I needed to take that 10 and make it into a fraction that has a denominator similar, or the same, I should say, as its fractional piece. So when I add those now, that is really 43 over 4 is what I have. So the same thing here. Remember, this 6 is really 6 plus 4/5. So what would be this 6 as a fraction that has a denominator of 5, right? So it would be 30 over 5, because 30 divided by 5 is 6. So 30 over 5 is the same thing as just 6. So now that's 30 over 5 plus 4 over 5, which is 34 over 5. So now I have two fractions. They were mixed numbers. Now they are the improper fraction version. And I'm still subtracting. Back as I said before, the only way to subtract fractions is with a common denominator. Well, 4 and 5 are not common denominators, so I have to convert them to get a common denominator. So the question is, what number does 4 and 5 both go into? Okay. If I look at it, 5 is a prime number, so really the best thing to do is just multiply those two numbers. When you have a prime number, your best bet is just multiply the two numbers to get that common denominator. In this case, it's 20. So I need to take 4, so I'm moving up to here now. I'm going to need to take 43 over 4 and convert it into something over 20. That's going to be my common denominator. I need to do the same thing with 34 over 5 and convert it into something over 20. Right? So again, we're looking at what would be that big giant 1 that I would multiply by in order for this to change the fraction without changing the value, right? If I'm going to multiply by something, it's a big giant 1. So what is my giant 1 in this case? So if I look at it, 4 times 5 is 20. Therefore, I have to multiply the top by 5 as well, because that's that giant 1. So 43 times 5 is 215. And then over here, same bit, I got to multiply 5 times what is 20? Well, 5 times 4 is 20. So therefore, multiply top and bottom by that 4, because that's that giant 1. So 34 times 4 is 136. Okay, so I have 136 over 20 for this one and 215 over 20. Now I can subtract them. Running out of room here, but we got this. So 215 over 20 minus 136 over 20. Okay, so keep in mind, let me go from the beginning. Review here. I took two mixed numbers, converted them to be improper fractions, then took those improper fractions and got common denominators. Now I can subtract. So I'm looking at 215 minus 136. all over 20. 20 is going to stay the same, right? Your denominators don't change when you're subtracting and adding fractions with a common denominator. Your denominator stays the same. My parts is what I'm subtracting. My whole stays the same. So I just need to know what is 215 minus 136. Let's see, I need to do that on the side here. So I'm going to go 215 minus 136. Okay. And I can. All right. And that's going to be 79. So I have 79 over 20 is my answer. And if I really want to, I can go ahead and change that back to a mixed number. Back to a mixed number. How many times does 20 go into 79? It goes in there 3 times, because then it's 60 with 19 left over. So the final answer could be 19.3 and 19/20ths. Okay. Or I would accept 79 over 20. All right. There we go. Final answer. Thank you all.